New Horizons to continue mission of discovery with Kuiper Belt encounter. Scientists planning the next phase of NASA's New Horizons mission, a robotic craft that completed the first exploration of Pluto in 2015, are going into the flyby of a frozen, faraway city-sized clump of rock on New Year's Day 2019, armed with little knowledge of the target, lurking around 4 billion miles, 6.4 billion kilometers, from Earth. Some of the object's profile will be filled in by the time New Horizons reaches it, but mission managers expect many surprises as the spacecraft zips past 2014 Mu-69, the target's official name, at a relative velocity of more than 9 miles per second, about 14 kilometers per second. The little world will become the most distant object ever visited by a spacecraft. I don't know if it's going to look like a little blackberry with little lumps that all came together, or if it's going to be a fragment of some larger body with an interior cut on one side and not on the other side, said Will Grundy, a co-investigator on the New Horizons team from Lowell Observatory. But it's going to be great fun, and this all starts happening at the end of next year. Scientists are not sure of the object's exact size. It might be anywhere from 13 miles, 21 kilometers, to 25 miles, 40 kilometers, across, Grundy said, or its shape, spin rate, color, or whether 2014 Mu-69 has any moons or rings. It's basically a point source, Grundy said, referring to the object's appearance in images from the powerful Hubble Space Telescope. We've seen no companions, but we're not very sensitive to small companions or close-in companions. We don't really know what its rotation period is. We don't really know what its light curve amplitude is. It looks like it might be red, but the error bars kind of include everything. Alan Stern, the New Horizon mission's principal investigator, said miniature worlds like 2014 Mu-69 are likely the leftover ice and rock fragments that formed larger objects like Pluto, the moons of some Uranus and Neptune, and other dwarf planets in the outer solar system. The small Kuiper Belt objects like 2014 Mu-69 that we're going to be flying out to in 2019 are thought to be the building blocks of the small planets in the Kuiper Belt, like Pluto and the others, Stern said in a Facebook Live event January 19, highlighting the progress of the New Horizons mission. The Kuiper Belt is a ring of ancient icy remnants from the earliest part of the Solar System's 4.6 billion-year history, circling the Sun beyond the orbit of Neptune. Its population includes continent-sized worlds like Pluto and the even farther dwarf planet Eris, and perhaps hundreds of thousands of objects the size of 2014 Mu-69 or larger. New Horizons launched 11 years ago, on January 19, 2006, flew by Jupiter for a speed boost in February 2007, and executed the first ever close-up encounter with Pluto on July 14, 2015. The spacecraft's instruments, including a telescopic camera, a color imager, and composition measuring spectrometers, found Pluto an unexpectedly exotic world with frozen nitrogen glaciers, a tenuous hazy atmosphere, and evidence of a possible liquid ocean and ice volcanoes. One thing that we discovered is that small planets can be just as complex as big planet, and that really blew away our expectations, Stern said January 19. We did not think that a planet the size of North America could be as complex as Mars or as the Earth, and yet that's what we found. In addition, we also found that Pluto is geologically alive, even today, that it's making new surface units, and that there are glacial flows and other kinds of activity on the surface that we didn't think could happen on a small planet billions of years after its formation, Stern said. We thought it would have cooled off by now, and run out of energy, but, in fact, it hasn't, and those two discoveries really changed the paradigm in planetary science and whet our appetite for future exploration of the Kuiper Belt. Scientists always hoped to keep New Horizons going after its historic Pluto flyby, but they found no suitable targets for the mission's second act until a special search with Hubble in 2014 discovered two potential objects within reach of the spacecraft's limited fuel supply. In August 2015, a month and a half after New Horizons zipped by Pluto, officials selected 2014 MU-69 as the favored destination for the probe's extended mission. NASA formally approved the plan last year. Earlier this month, Grundy told NASA's Small Bodies Advisory Group, a forum for researchers focused on asteroids, comets and related solar system objects, that ground controllers are beginning to erase the data recorders on the New Horizons spacecraft after the robot finished downlinking the last of the data it collected at Pluto. It's a careful process because managers want to ensure nothing gets inadvertently deleted from the spacecraft's memory drives. We're working to erase the solid-state recorders because we need to make room for new Kuiper Belt data, Grundy said. Of course, you don't want to jump the gun on that, but we need to make room, so we're having both the instrument teams look at what's on the ground, as well as the science teams. So it's both the producers and the consumers of the data who are checking off and saying, yes, that really does look intact on the ground. Scientists know the approximate size and orbital trajectory of the distant object now in New Horizons' sights, but little more. Pluto's about the size of North America, and the next object is more like the size of the Chesapeake Bay or the Great Salt Lake, said Kelsey Singer, a member of the New Horizons Geology and Geophysics team from the Southwest Research Institute. These smaller objects, we think, are probably more pristine and more primordial, so we're going to learn about the building blocks of the solar system by going there. Astronomers have studied 2014 MU-69 for less than 3 years, leaving many questions about the distant destination unanswered. One piece of data sought by New Horizons scientists is the exact location and motion of the target. That will be aided by repeated observations by Hubble and the European Space Agency's Gaia Observatory, which is surveying the entire sky to pinpoint the positions and movements of more than 1 billion stars, asteroids and other objects. Planning for the complicated sequence of picture-taking, composition scans and other observations scientists want New Horizons to capture at 2014 MU-69 is already underway. It took 4 years to develop the fine-pointing commands, instrument activations, and fail-safe computer logic needed for the spacecraft's high-speed visit to Pluto. For the January 1, 2019, encounter with 2014 MU-69, scientists and engineers have 18 months to finalize their plans. Stern and Grundy said the ground team is working on 2 flyby scenarios for 2014 MU-69. One of the flight plans would likely have New Horizons fly within 1,900 miles, 3,000 kilometers, of the object, a range that would allow the spacecraft's main camera to see features as small as buildings, Singer said. Officials have not picked a precise distance for the encounter. That will depend on updated orbit and motion data from Hubble and Gaia. Similar to the backup plan developed leading up to the Pluto flyby, Stern said the ground team will work on a bailout option for New Horizons in case the craft's cameras spot rings, moons or debris surrounding 2014 MU-69 in the weeks before closest approach. In such a case, New Horizons could be steered on a path slightly farther from the object to ensure it does not collide with dust or ice. Such debris strikes could be fatal to the spacecraft at the projected flyby velocity. By mid-year, scientists hope to nail down an estimate for the target's rotation rate by analyzing Hubble data, but much of the flyby sequence will need to be designed before planners can incorporate that knowledge, Grundy said. Astronomers also plan to watch 2014 Mu-69 pass in front of a star later this year. The dimming of the background star, called a stellar occultation, could tell scientists more about the object's size and shape, and possibly reveal dust clouds, rings, or moons accompanying it. But the object's modest size means the occultation will only be visible from a narrow band of territory. A network of astronomers around the world and NASA's Airborne Infrared Observatory, known as SOFIA, will try to catch the act. This is going to be very challenging, but valuable, Grundy said of the Earth-based observing campaign. Meanwhile, engineers at New Horizons' Mission Control are fine-tuning the probe's trajectory with a series of course correction maneuvers by the craft's rocket thrusters. As we learn more about the orbit of 2014 Mu-69 and know exactly where we need to head, we'll execute some more of these maneuvers, possibly as many as 10, said Helene Winters, New Horizons project manager at the Johns Hopkins University Applied Physics Laboratory in Laurel, Maryland. 4 rocket burns in late 2015 did most of the retargeting, but engineers believe more are needed, beginning with a maneuver scheduled for February 1, Winters said in the Facebook Live event last week. The science team also intends to take pictures of up to 24 other known Kuiper Belt objects over the next year and a half. The spacecraft will not get close to those bodies, they will be millions of miles away, but New Horizons will be much closer to them than any telescope. This is the first time we've had essentially an astronomical observatory in the Kuiper Belt looking at objects that are too faint to study in this way from the Earth, said Stern, a scientist based at SWRI. Measurements of the solar wind and plasma environment in the outer solar system are also on the mission's docket. NASA has committed to fund the New Horizons mission through 2021, when all the data gathered from the January 2019 flyby should be back on the ground. It will take even longer to downlink science data from New Horizons after the visit to 2014 Mu-69 and the 15 months needed to return all the observations of Pluto. At the vast distance to the mission's next destination, it will take more than 12 hours for radio signals to travel the round trip between the spacecraft and Earth, and the transmission rate will slow to a crawl. New Horizons could be granted another mission extension after 2021 to continue monitoring its surroundings as it escapes the solar system, following in the footsteps of the trailblazing Voyager probes. The craft draws on the heat from a plutonium power source for electricity. The spacecraft is about 400 million miles, 643 million kilometers, beyond Pluto and some 3.5 billion miles, 5.6 billion kilometers, from Earth, and it's doing just fine, said Glenn Fountain, former project manager for New Horizons, during the Facebook Live event. All the systems aboard are working. We have plenty of power to continue the mission out, though the Kuiper Belt flyby we'll do later, and further beyond that. The power decreases as we get further away in time because the plutonium on board has about an 80-year half-life, so it's slowly losing power, but we can still run until about the mid-2030s, Fountain said.
When you back it up and you drop it down low.